For this integrand, we have the following rational function. When you have your partial fractions, there really isn't much need to simplify our integrand. Rather, we can proceed almost immediately. All we need to do is get the factors of the denominator. So for our denominator, x squared plus 5x plus 6, its factors are x plus 3 and x plus 2. With the factors of the denominator known, we can break apart this particular integrand so that we get two new integrands, each integrand having a simpler rational function on it. So, we now have the following. X squared minus 8 all over x plus 3 times x plus 2 can be broken down into two partial fractions. Each partial fraction having as its denominator one factor of our original integrand. So our first simpler integrand is a over x plus 3, and for the second one, that's b over x plus 2. Now it's only a question of finding what the values of a and b are, and once we already know them, then we can easily integrate this one. So let's get on to it. Let's find the values of a and b. We now try to multiply both sides of this equation with our original denominator, which is x plus 3 times x plus 2. So multiply everything in here by our denominator x plus 3 times x plus 2. We get x squared minus 8 equal to a times x plus 2 plus b times x plus 3. Now, all we need to do now to get the values of a and b are assign values of x. It's fortuitous for us to assign, for instance, x equals to negative 2. The reason for that is, if you assign negative 2 here, we'll get the following expression. Now, negative 2 plus 2 will be 0. And so this term here, the a term disappears, and only the b term will remain. Thus, we can easily get the value of b. So doing that one, substituting negative 2 to the x, we get the following. So b is now equal to negative 4. So likewise, to get the a, it's best for us to assign x equals to negative 3. In that way, this b term over here will become 0, and only a will remain. So let's do that one. Assigning x equals to negative 3 now, we have this. So as said, the b term, the terms over here, will just simply become equal to 0, and leaving us with only the value of a. So with that, the value of a, we compute a is now equal to negative 1. So with those values computed, we can now easily replace a and b here with the appropriate values. Thus, we now have the following new integrals. So from our original rational function, we get two simpler integrands, which can easily be integrated to give us the following answer.